A supermassive black hole may be running away, not wobbling around the center, not a little off, running. And that sounds impossible for a reason. Supermassive black holes are the anchor bolts of galaxies. They sit in the middle for billions of years while everything else orbits, falls in, or gets pushed out. So when astronomers digging through James Webb Space Telescope data pointed to a bright, active black hole candidate that doesn't seem to sit where the galaxy's center should be, plus a long, strange feature behind it that looks like a wake, the reaction wasn't celebration. It was, wait, what could possibly do that? Because black holes are invisible. You almost never catch the thing. You catch what it does to the universe around it. So here's the deal. In the next few minutes, I'll show you the clue that made scientists take this seriously. The only two realistic ways a monster like this can get launched, and the one test that will decide whether this is a real runaway or a cosmic coincidence that just looks perfect. First, what was actually seen? Think of a crime scene where the suspect is invisible, but the floor is scraped and the walls are scorched. You don't need the suspect on camera if the room itself is telling you something heavy moved through it. Researchers point to two main clues. Clue 1. An extremely bright, active black hole candidate that appears displaced from where you'd expect the galaxy's true center to be. In most galaxies, the strongest black hole activity is tied to the central region. Off-center activity can happen, sure, but when it's this pronounced, you stop and ask why. Clue 2. A long, narrow feature stretching away from that source. An extended structure that could be consistent with a wake. The logic is simple. If something massive and energetic is moving through gas, it can compress material in front of it and disturb material behind it. Now, a trail in space is not proof. Galaxies collide. Tidal debris stretches out, gas filaments form, random alignments happen. But what makes this case interesting is the coherence of the scene. A bright, engine-like source, plus an extended structure that lines up in a way that suggests direction, like something went through, not something that merely exists. And Webb matters because it's brutally sensitive. It can reveal faint structure in dust and gas that older observations can miss. In other words, it doesn't just show the bright dot, it shows the surroundings, the context, the aftermath. So the claim on the table is not, we photographed a black hole sprinting. It's, we may be seeing the fingerprints of a massive object that has been displaced and might be moving. And if that's true, the next question is unavoidable. What event could kick a supermassive black hole so hard that the galaxy can't keep it seated at the center? There are basically two believable answers. Both are violent. Mechanism 1. Gravitational-wave recoil. The kick. When two galaxies merge, their central black holes can eventually spiral together and merge. That merger releases energy as gravitational waves, ripples in space-time. If the waves leave perfectly evenly, the merged black hole stays put. But perfect symmetry is rare. If the masses are unequal or the spins are tilted, the waves can carry away momentum unevenly, and momentum has to balance. So the newly merged black hole recoils, like a cannon firing, but in space-time. In extreme cases, that recoil can shove the black hole out of the galactic center and send it on a long journey. Mechanism 2. The three-body slingshot. If a third supermassive black hole enters a region where two are already interacting, gravity turns into a chaotic tournament. In three-body dynamics, stable is rare. Usually, one object gets ejected and the remaining pair tightens. Translation: in a three-black hole mess, somebody gets thrown out. So yes, under rare conditions, a supermassive black hole can be launched. But launching it is only half the story, because if a black hole is moving through gas, it should leave signatures that are hard to fake. Which brings us back to the strangest part of all, the trail. A black hole by itself is invisible, but a feeding black hole is not subtle. Gas spiraling in heats up and becomes incredibly bright. Active black holes can outshine entire galaxies in certain wavelengths, not because the black hole glows, but because the gas around it is screaming hot. Now imagine that bright engine is not sitting calmly in the center, but moving through a gas-rich environment. Gas in front of it gets compressed, some gets heated, some gets pushed aside. Behind it, disturbed gas can cool and collapse into new stars. So a moving, active black hole could produce a visible path. Not a magical line, but a region where the environment looks different because it was disturbed. One analogy is actually useful here. It's like a ship's wake. You don't need to see the engine under the water to know something passed through. The pattern behind it is evidence of motion plus interaction. But space is full of wakes that aren't wakes. Merger debris can look like trails. Gas filaments can look like paths. Projection can line things up by chance. So the real question is, does this scene tell a directional story, or just a visually tempting one? Skeptics zoom in on two pressure points. 1. Is the trail truly connected to the black hole candidate, or is it just nearby? If the extended feature is unrelated, say tidal debris from a merger, then the alignment could be coincidence. The black hole could be active for its own reasons, and the trail could be a different story happening in the same neighborhood. 2. Are we sure about the galaxy's real center? In messy merger systems, identifying the true center is harder than it sounds. Dust can hide regions. Multiple bright clumps can confuse the picture. What looks off-center at first glance can shrink after careful modeling. So the responsible stance is interesting, plausible, not confirmed. But here's why this is worth your time. There's a very specific kind of evidence that can push this from cool candidate to, okay, that's real. If this is a runaway black hole, the environment should tell a directional story, not just a pretty shape. Here's what astronomers would want to see. 1. An age pattern. If the trail involves triggered star formation, the stars along it shouldn't all be the same age. You'd expect a gradient, older farther back, younger closer to the source. That turns the trail into a timeline. 2. Shock-like fingerprints. If the source is moving fast through gas, gas in front of it should show a different temperature and density pattern than gas behind it. Not, it looks pointy, but the physics matches motion. And if they can measure how gas is shifting, toward us or away from us, that adds a velocity story, not just a shape story. 3. Evidence at the galaxy's core. If the black hole was kicked or slingshotted, the central region should look like it went through something. Disturbed structure, merger scars, maybe even another black hole candidate still near the core if a three-body interaction happened. Those tests are hard, but they're doable. And that's why this story matters. It's a claim that can be confirmed or killed with better data. Here's the final twist. Even if this specific case turns out to be coincidence, it still teaches us something. The universe is complicated enough to fake dramatic stories, and we get better at not fooling ourselves. But if it holds up, if the motion story becomes real, then a rule we treat like a default setting is not guaranteed. That galaxies always keep their central supermassive black holes. It would mean some galaxies have had their anchor ripped out. Some could have black holes wandering far from the center, and some runaway black holes could be roaming intergalactic space right now, almost invisible unless they happen to feed. So here's the question to leave you with. If we've already found a candidate like this, how many more are out there, hiding in plain sight, simply because we weren't looking for a galaxy that lost its heart? And tell me in the comments, real runaway or cosmic coincidence? Either way, the next observations will decide.